We are going to solve bit strings problem of CSES problem set. So our statement is like your task is to complete the number of bit strings of length n. For example, for 3 we get 8 as an answer because we uh, we have 8 bit strings are available like this. And we have to take an input and we have to print the result in modular form. So these are the constraints which has to be 10 to the power of 6. We thought if the constraints are less than 10 to the power of 9, we can use integer variable, integer data type. But here we have to use long int. We use modulo because of we use modulo because it prevents the integer overflow. Yes, and let's discuss about the problem. For 3 we got 8 as an answer. For 3 we got 8 as an answer because we have 8. We have 8 bit strings for 3 answers. For 3 we have 8 bit strings, and for 2 we have 4 as a bit strings like 0001 1011, and for 1 we have 2 as an answer because we can either get 1 or 0. So for 2. So observe these 3 patterns, like for 1 we have 2, for 2 we have 4, for 3 we have 8. So it shows it's something power of 2. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So for 4, we got like 2 to the power of 4, which are equal to 16. Like, so for 4, we got 16 as the answer. So this is enough for our problem. So what we have to print, we have to print the to the power of n. So we have to take the number n and we have to print the to the power of n to the power of n. So, but here the we have to print, why we need to print the result in the modulo 10 to the power of 9 plus 1, because at some point in integers uh, the operation 2 to the power of n causes the integer overflow. So for preventing this, we are actually using modulo operation. For preventing this only, we are actually using modulo operation. So when we use exactly the modulo operation, okay, we know that modulo operation is used for both addition of two numbers and product of two numbers, which causes it not lose the answer, because if you get the answer less than that modulo, you get the answer, or because if you get 5, so like 2 divided by 5, so we get an answer like 2. So the modulo result of this operation is 2, but 2 and 5, we get modulo answer as 4. No, sorry. We get modulo answer as 1. Okay, you got it. So when the bigger number is divisor, then we get the middle number, like dividend as the answer. If it is not, we get the number which is less than that dividend. Okay. So this is how modulo operator works. Thus, the code, this is the code. We have to take a number and we are reading that number. So this is the result. As we have to multiply, I have to initialize this result to 1. And this is the code. We have to decrement the n, because what we are actually performing 2 into 2 into 2 into 2 up to the n times. So yeah, this is the result, because 2 into r, 2 into r. Whenever the 2 into r is actually greater than the mod, In that time only, I'm actually use model operator in order to reduce that number after this, uh, without never losing its value. When only it's greater than the mod, it loses its value. Okay. And then in the end, I'm printing that number. So let's check this. Okay, first of all, I'm giving one. We get right. So if you are giving three, then we get eight. Okay. If you are giving zero, we get what? One. Because why? In this case, there may be a chance for zero and one. Right? So if we give one, we get one with was zero and one both. We give it the 24 of three, which is okay. So we give is number of bit strings. Okay, let's wait. I have the same file in my local disk. So bit strings. Okay, this is my file. So submit. So it is accepted. Thank you to all.